Okay, so today we're going to start our review of trigonometry, and we're going to take a look at the things that we've looked at so far, the stories so far. So really for us, we began our study with the three primary trig ratios. So we have SOHCAHTOA, we have sine, cos, and tan that we know. We realize that these three primary trig ratios, remember, are all built up off an angle, a primary angle, theta. We have a right angle triangle to use three primary trig ratios. Theta is in one of the corners. It could be up here in this corner, but we'll just throw it down here. This is our theta, our primary angle. Then the sine ratio is the opposite over hypotenuse. Cosine ratio is the adjacent over hypotenuse. And the tan ratio is opposite over adjacent. So remember, it's sine theta, cos theta, tan theta. It's always relative to our primary angle theta. You have to identify that. So really the trig allowed us to find the heights of inaccessible things. So we did a little experiment with a tree, and suppose there's a building, and you want to know how high the building is, but you can't actually go and measure it. Well, what you can do is you can actually model a right angle triangle from the ground up to that building, and we can actually measure the distance on the ground. So knowing this distance here, which we can determine, knowing that primary angle theta as 50, that we can measure, we can determine that. The question would be, what is our h? Well, this is my primary angle theta. This is the opposite. This is the adjacent. So I know tan uses opposite and adjacent from SOHCAHTOA. So tan 50 equals h over 150. This is a proportion. It's an equation. Tan 50 is a number loaded into your calculator. 150 is obviously a number, and h is our only unknown, so we can solve this. To do that, we just multiply both sides by 150. Of course, this divides out here. And that leaves us with 150 on this side times tan 50. Use your calculator, plug it in. Make sure you are in degrees, as always, in your calculator. Okay, we haven't done radians yet, so make sure you are in degrees. And this would be around 178 meters for the height. We could also find, even greater lengths. Imagine you're in an airplane and you're flying and you want to land, but it's not sunny, it's cloudy, and the pilot can't see the ground. So what the airport does is they shoot a laser from a certain distance away, then they shoot a second laser up and they meet a certain spot on the clouds, and then of course they can create a right triangle with this. They can measure the distance along the ground as 1,000 meters, usually a kilometer. That's why airports have to be so big and flat, is they need a lot of space to get this, well, for runways of course, but they need a lot of space for this measurement. They can also measure this primary angle just using a pretty simple device. And what they can do is build this right triangle and determine h, the height. So again, this is an example of tan. Tan is opposite over adjacent. Tan 43 is h over 1,000, right? The same as always, multiply both sides by 1,000, divides out on the right-hand side. Use your calculator and just type in 1,000 times tan 43, and you should get 937 meters. That would be the height, how high the clouds are above the airport. And they would then, radio that information, up to the actual plane just to let them know how far the ground is below the clouds. The clouds could be at a different height, obviously lower. Same idea. If the clouds are lower, that means the beam they shoot up to the clouds would be less. It would be lower, the angle. So in this case, it wouldn't be 43 degrees. It would still be 1,000 meters on the ground. This device over here doesn't move. But what changes is the angle. It's now a lower angle. It's now 25. So if I were to build my ratio, this is of course h. It's a right angle triangle. I build a ratio, tan 25 is h over 1,000. I do my calculations, and I get a lower number, obviously, for h, 466. So the height now is lower. The clouds would be lower. And then they would then communicate that idea up to the airplane. So there's some general, just some quick SOHCAHTOA questions. Give me some information. What do we use here? Sine, cos, or tan? Take a second, see if you can recognize it. Okay, this would be cosine, because this is the adjacent, and this is the hypotenuse. It's all relative to our primary angle here. So adjacent and hypotenuse. So it's cosine. We'd write the model, and then let's just solve for a. Using your calculator, 15.4. What about this one? Take a second. Okay, this would be sine. because we have opposite and hypotenuse. This is the opposite. This is the hypotenuse. Remember, this is our theta here. The opposite is the far side. It's on the opposite side of the triangle because it's on the far side. The side down here is the adjacent side because it's adjacent to the angle. That's sort of the thinking on it. Anyway, sine 37 opposite over hypotenuse. You crank it in, multiply it out, and you get 6.02 in this case. Last one. Well, you could probably guess we had a sine and a cos. This is obviously going to be a tan. So we have tan 63 is opposite over adjacent. I just put theta up here in this corner because, again, it can be up here or down here. It doesn't matter. It's never the 90. It's just one of the two corners. So it's just as easy to have theta up in the upper corner. This is theta here. A is the opposite. 10 is the adjacent. So opposite over adjacent. Multiply both sides by 10, and you got it. So if we don't have a right angle triangle, then we have to use two other laws. The first one we looked at was called the law of sines. So suppose in this case I want to, the law of sines here basically says the sine of this angle A, so the sine of A divided by the side opposite is equal to the sine of angle B divided by the side opposite is actually equal to the sine of angle C divided by the side opposite. Those are the proportions that we use. So keeping that in mind, given a triangle, we can use the sine law to write something. Suppose I want to figure out what angle R is. Well, R is the unknown, so I'm going to write that on top. So I'm going to say sine of R, which is my angle here, divided by the opposite side, 41, has to equal my known angle here, sine of 39, divided by the side opposite that, which is 28. So here's my equation, and I have one unknown. Remember, sine 39 is a number, obviously 28 and 41 are numbers. This is my only unknown up here as sine R, so I can solve this. I would use my calculator. I would start here. I would just type in sine 39, and you get that long decimal number, so you may have to hit equals after it, maybe not. Sine 39, I would then divide it by 28 and hit equals. And then, of course, I'm going to multiply it by 41 because I'm really going to multiply both sides by the 41. And when I do that, of course, it divides it out over here, and it leaves me with just sine R. So when you do that, you should end up with, use your calculator, try it. Go sine 39 divided by 28 times 41. You should get a number around 0.9215, something like that. Now, obviously, when you look at that, that can't be angle R, right? I mean, angle R isn't 0.9 degrees. That would be almost like two parallel lines. It's because this is the sine of R. So don't forget, to get actually angle R, we have to use that sine -1 button on our calculator. Okay, sine inverse, it's also called arc sine. Okay, when you type that in, so sine -1 of this decimal number, okay, then you will get a value for R. You will get the R being around 67 degrees, which kind of makes sense. It looks like, 45 would be about there, so it's more than 45. So yeah, 67 could be the angle. Okay, you're going to have to double check your calculator on this because we talked about this before in class. The calculator manufacturers are different. And sometimes you put the angle first, sometimes the sine is first, sometimes you have the button, then the shift. So the calculators are different. So you have to figure those out because I can't tell you how to do them on your specific calculator because we're not in class. So these are the numbers you're looking for. Okay, try this side, get the 0.92, and then shift sine to get the 67 degrees. The last thing we would use is the law of cosines, okay, which is just saying it's almost like a cranked up version of Pythagorean theorem. So it's saying c squared, which is here, c, so the length of this side, so it's going to give us the length of this side, it's equal to a squared plus b squared, so just the other two sides squared, take away 2ab cos of the angle c. So the cosine law does link together sort of at the beginning and the end, the side and the angle across from it. So it does have this pairing that we have to keep in mind. So in this case here, suppose I want to try to find the length of side C. So I would build the law c squared equals, now the other two sides, the order I use doesn't matter because I'm just adding them anyway. So I can go 11 squared plus 8 squared minus 2, 11, 8 cos of 37. And I think in class we ended up pretty much going left to right on this. Your calculator will recognize order of operations. So I would just crank it in. 11 squared plus a squared minus 2 times 11 times 8 times cos 37. Hit equals, and you should get something around 44.4-ish if you have it done properly, okay? Now, of course, C can't be 44, right? That's 11, and that's 8. There's no way C is 44. So we realize, remember, the formula is C squared. So I don't want C squared, I want C. So to actually get C, I have to square root my 44.4, whatever I had, and it ends up being around 6.7. And there's no units here, so I'm just going to put units. And again, you have to double check the steps on your calculator to make sure it works for your calculator itself. Okay, and that's it. I want you to take a look at page 221. These are just review questions, 1 to 12. There's a lot there, but you know what, you have some time, so take your time, work through them, and we'll move on to the next step of Trig soon. Okay.